Imagine for a moment, standing at the edge of our understanding, gazing into the boundless void of space. What if I told you that we've just discovered something that should not exist? A galaxy, one that defies everything we know about the universe and its origins. A cosmic anomaly, a celestial enigma that should be impossible by every rule we've ever written. And yet, there it is, staring back at us from the depths of the cosmos. A galactic surprise that challenges our most fundamental beliefs about the formation of the universe itself. The moment scientists caught a glimpse of this galaxy, they were left speechless. It's a discovery so rare, so profound, it could rewrite the history of our universe. This is not a fantasy. It's not a glitch in the matrix of space. It's real, and it's happening now. Let's dive in. It all started with a routine survey of the night sky, conducted by an international team of astronomers using the cutting-edge power of the Hubble Space Telescope. Their mission was simple: to map distant galaxies, study their formation, and understand the vast network of stars that populate our universe. But as they sifted through data from the deepest reaches of space, they stumbled upon something they weren't expecting, something that would make even the most seasoned astronomers pause in disbelief. The discovery came as a fluke, a serendipitous accident. The team had been analyzing light signatures from distant cosmic objects when they noticed an anomaly, a faint, ghostly glow that seemed to break all the known rules of galaxy formation. At first, they thought it was a mistake, a trick of the light, or perhaps some sort of cosmic background noise. But when they dug deeper, the data didn't lie. This galaxy, which they eventually named Galaxy Z, was located over 13 billion light-years away, placing it in the early days of the universe. The twist: its structure, its age, and its composition were completely at odds with what was expected. By all known models, galaxies in the early universe should have been small, irregular, and chaotic, barely forming any stars at all. But what they found in Galaxy Z was far more than just another space rock. It was a mature, massive galaxy, complete with a rich stellar population and complex structures. The implications were staggering. But here's the kicker: this discovery wasn't made by a high-profile space mission or a giant observatory. It was the product of an unlikely collaboration, a team of passionate scientists, a historic telescope, and a stroke of cosmic luck. What they had found was something that would forever alter our understanding of the early universe. Galaxy Z, as it's been dubbed, isn't just another distant galaxy. It's a cosmic riddle wrapped in the fabric of space-time itself. Imagine, for a moment, that the universe is a grand canvas, and galaxies are the brushstrokes of creation. Most of the time, those brushstrokes are chaotic, messy, or incomplete in the early stages of the universe's life. But Galaxy Z is different. It's like a masterpiece that somehow appeared before the artist was even supposed to pick up the brush. Let's start with its size. Despite being so young at just over 13 billion years old, Galaxy Z is already massive, about the size of the Milky Way, if not larger. To give you some perspective, the Milky Way, our home galaxy, contains around 200 billion stars. Galaxy Z, however, has already gathered hundreds of billions, if not more, stars in its relatively short lifespan. It's like a cosmic overachiever, growing at an extraordinary pace, even though it should still be in its formative stages. Its structure is equally perplexing. Galaxies in the early universe are supposed to be wild, irregular, and in the process of being pieced together. They shouldn't have the kind of smooth, organized spiral arms or dense core that we see in more mature galaxies like our own. But Galaxy Z flips that idea on its head. It has a well-defined, disc-like shape, resembling a galaxy in its middle age, with a clear central bulge and even hints of spiral arms. It's as if this galaxy skipped several chapters of cosmic development and went straight to maturity. Then, there's its star formation rate. In most galaxies, especially those formed early in the universe, stars are born slowly, like a trickle of water flowing from a distant mountain spring. But Galaxy Z is different. It's forming stars at a furious pace, much faster than what we'd expect from a galaxy so far in the past. It's almost like watching a wildfire, each star being born in a blazing, energetic process, while most galaxies in that era would have been more like a small, slow-burning ember. What's truly mind-boggling is how this galaxy seems to have bypassed the typical evolutionary path. In the early universe, gravity would have been the primary force pulling matter together to form galaxies. However, this process takes time that Galaxy Z seems to have skipped over. Some astronomers theorize that it might have formed in a different way, possibly influenced by other forces or conditions we don't fully understand yet. It could be a result of dark matter, an unseen force that permeates the cosmos, and could be playing a part in the galaxy's unusual formation. Or perhaps it's something even more mysterious, like an unknown aspect of gravity or dark energy itself, forces that behave differently in the ancient universe. When you imagine Galaxy Z, picture a swirling mass of light, energy, and motion, like a giant cosmic whirlpool. Stars flicker to life across the galaxy's expanse, some burning with the intensity of 1,000 suns. Nebulas form in the corners, their colorful gases mixing in the darkness of space, but instead of the erratic, messy birth you'd expect. From such an ancient galaxy, everything feels more mature, more purposeful. In essence, Galaxy Z is an anomaly, a cosmic contradiction. It's both a glimpse into the past and a glimpse into the unknown future, a paradox that leaves scientists rethinking everything we know about galaxy formation. The discovery of Galaxy Z is more than just a scientific curiosity. It's a monumental breakthrough in our understanding of the cosmos. To fully grasp its importance, we have to consider the history of our universe. The birth of galaxies is a process that's taken billions of years to unfold. Over time, galaxies have evolved, merged, and grown into the sprawling systems of stars, planets, and black holes we see today. But there's one thing all galaxies share: they follow a general pattern of growth, a pattern that Galaxy Z defies in the most spectacular way. The last time something even remotely similar happened was nearly 50 years ago, with the discovery of irregular galaxies that didn't fit the expected mold. But even these galaxies weren't like Galaxy Z. What makes this discovery so rare is that it happens in a time and place where it shouldn't. Galaxy Z is not just a random anomaly, it's a clue, a piece of the cosmic puzzle that suggests our current understanding of galaxy formation is incomplete. It's like finding a fossil of a species thought to have been extinct for millions of years. Only this fossil is pointing to an entirely new chapter of the evolutionary story. This galaxy has the potential to reshape our understanding of the very forces that govern the universe. What does it tell us about the early conditions of the cosmos, before stars and galaxies had fully formed? Could it have been a catalyst for the formation of other galaxies, or perhaps even influence the birth of planets? These are questions that will take years to fully answer, but one thing is clear: Galaxy Z is a reminder that the universe is far more complex and surprising than we ever imagined. Think about it. Every time we discover something like this, it reshapes the course of human history. The very study of space exploration and astronomy is an act of unraveling the origins of existence. Galaxy Z isn't just an event in the cosmos, it's an event in human history, a chapter that will be studied for generations to come as we continue our quest to understand the universe and our place within it. This discovery is a cosmic gift, offering us new insights into the unknown chapters of the universe's past. And, for all we know, this may be a once-in-a-lifetime event, an encounter with the deep mystery of creation itself. This is the moment. Scientists realize that everything they thought they knew about the formation of galaxies might be wrong. As they analyzed more data, something incredible happened. The team discovered that Galaxy Z wasn't just a random anomaly, it was somehow too perfect, too well formed for its place in time. It was as if the galaxy had been designed, or at least influenced by forces far beyond what we can currently comprehend. What happened next changed everything we thought we knew about the universe's origins. The data revealed that Galaxy Z wasn't simply forming stars at a rapid rate, it was actively defying the fundamental processes we've relied on for decades. For a galaxy to appear so fully developed, so quickly, it would require conditions that simply weren't supposed to exist in the early universe. In fact, the conditions needed to form such a galaxy would have been impossible to achieve, given the existing models of cosmic evolution. But there was one more revelation that would leave scientists speechless. Galaxy Z appeared to have somehow jumped ahead in time. It had advanced far beyond what should have been possible for its era, in a way that scientists have never observed before. It was as though the universe itself had decided to break its own rules and show us something far more extraordinary than we could have ever imagined. Imagine that moment. The room full of astronomers staring at their screens, their minds racing as they process the data. The implications were staggering. If Galaxy Z existed, it meant there could be other galaxies out there, hidden in the deep reaches of space that we had no idea about. It suggested that our universe might be capable of far stranger phenomena than we had ever dreamed of, and it forced everyone to ask the question, what else are we missing? In that instant, the future of astronomy was forever altered. This discovery had opened the door to a new era of cosmic exploration, one where our very understanding of space and time might be on the verge of a radical transformation. For all the cosmic grandeur of Galaxy Z, its discovery is not just a breakthrough. For scientists, it's a moment that belongs to humanity as a whole. This is a chance for us to glimpse into the distant past, to see the universe as it was more than 13 billion years ago. But what's even more fascinating is that, in some ways, this discovery is accessible to all of us. Anyone with a backyard telescope could witness history in the making, and perhaps catch a glimpse of this galaxy from Earth's surface as it hovers faintly on the edge of our perception. While its distance makes it nearly impossible to view, without the aid of powerful telescopes, the idea that it's out there, waiting for us to discover, creates a sense of collective wonder. What can we learn from this? For one, this discovery challenges the very nature of how we understand cosmic evolution. If galaxies like Galaxy Z could form so quickly, it opens up new avenues for exploration. Could there be other galaxies out there just like it, hidden in the deep recesses of space, waiting to be uncovered by the next generation of astronomers? This raises questions about the very mechanisms that govern star formation, galaxy structure, and the forces that shaped the early universe. But perhaps most importantly, this discovery underscores the power of citizen science. While professionals rely on advanced telescopes and deep space probes, the role of amateur astronomers is becoming more critical than ever. Through public telescopes, global collaborations, and crowdsourced data, we now live in an era where anyone, anywhere, can contribute to the ongoing exploration of space. Galaxy Z is not just a scientific discovery. It's a shared global wonder, one that invites all of us to look up at the stars and remember that we are all a part of this grand cosmic adventure. As we stand on the precipice of this monumental discovery, the future of space exploration looks more thrilling than ever. Galaxy Z isn't just an anomaly. It's a beacon that will guide the next generation of space missions. Its existence forces us to reevaluate everything we know about galaxy formation, and in turn, it will fuel the development of new, more advanced technologies to study galaxies beyond our current reach. Looking ahead, missions like the James Webb Space Telescope are poised to play a crucial role in unraveling the mysteries of galaxies like Z. With its unprecedented ability to peer deep into the infrared spectrum, Webb will allow us to study these early galaxies. in greater detail than ever before, potentially unveiling even more galaxies that defy our current understanding. The upcoming launch of the Nancy Grace Roman Space Telescope will also complement Webb's work, providing wider field views of the universe and enabling astronomers to map these distant regions with precision. But it's not just about big missions and space telescopes. The future of space exploration is also deeply intertwined with the role of artificial intelligence and machine learning. As data from space telescopes flood in, AI will help us sift through it more efficiently, identifying patterns and anomalies that may otherwise go unnoticed. Who knows, perhaps the next Galaxy Z will be discovered by a computer, not a human eye, and we'll be looking at an entirely new class of galaxies. What's clear is that this discovery is just the beginning. It challenges us to ask bigger questions about the universe. How many more galaxies like Galaxy Z are out there, waiting to be discovered? What cosmic phenomena still lie beyond the horizon of our understanding? As we venture further into space, each discovery will peel back another layer of the great unknown, leaving us with even more mysteries to explore. The universe is vast, and it's full of wonders we've yet to even imagine. As we gaze into the depths of space, discoveries like Galaxy Z remind us of our tiny yet profound place in the cosmos. The universe is a vast, mysterious expanse, full of secrets waiting to be uncovered. With each new revelation, we inch closer to understanding the very forces that shape our existence, and in doing so, we realize that we are part of a story much bigger than ourselves. So, as we continue our journey through the stars, let this discovery inspire you to keep looking up, to keep wondering, and to keep dreaming. The universe has so much more to show us. If you want to continue exploring these cosmic mysteries, don't forget to subscribe. Until next time, clear skies and cosmic dreams.